Now, in this next section, I would like you to look at another transmission line which is fairly popular called the stripline. And a stripline is basically almost the same as the microstrip, except that we essentially fill the other half space that before was unfilled with the same type of dielectric. So now epsilon r is everywhere. It surrounds the stripline. The stripline is basically in between two grounds. So you have a ground on the top and you have a ground on the bottom. And as you can probably already imagine, we have now solved a number of microstrip drawbacks. One of them, if you remember, is that we had non-uniform dielectric. Now we do have a perfectly uniform dielectric, which basically means that this line can actually support a pure TEM mode. It's not a quasi-TEM mode, it's a pure TEM mode, which means that this behavior is far better as a function of frequency compared to the microstrip line. A TEM mode has no dispersion, and so that means that this transmission line is far more ideal than microstrip line actually is. The other advantage of this line is actually the fact that radiation is severely reduced compared to microstrip. Unfortunately, in microstrip line, because you have a lot of electric fields actually are in the air, you basically suffer the issue of radiation, particularly as you make the microstrip line wider and wider. In a strip line, there is nowhere for radiation to go, radiated energy to go, because you have this thing fully controlled with two ground planes. And the only drawback that you may have here in terms of radiation is, again, if you somehow fail to balance the voltages for the two grounds. So if you have any type of voltage imbalance, there will actually be some parallel plate capacitive mode between the two grounds, and that is definitely an undesirable effect. What's the drawback of this thing? Well, it's clear: complexity and cost. So it's a higher cost line because it's a more complex line. And so if you really don't need this high performance, and then we don't usually bother to do this. I also wanted to mention that this idea of building a homogeneous dielectric around your main strip line is not just for the microstrip versus strip line application, but we also do it for coplanar waveguides. We do it, for example, coplanar strip lines, I should say. This differential line I showed you before, we can have a fully embedded differential line to essentially get the same type of advantages.